Hello everyone. Hello guys. Tell me about audio and video. Is it clear? Is it clear? Tell me about audio and video. I think it's clear from my side. I hope it is clear from your side as well. Okay, so good evening everyone, and in today's session we will discuss about control system and control system from last 3 years. PYQs. Okay, it's 2002 and 2008 and 2016. In those years, ISC has conducted the GATE exam, so it will help you to understand what is the level of the questions when ISC is conducting the exam. So you'll get the good idea about that, and you will get the important areas in which ISC select the questions. Okay, so let's start this session, and let's not delay it. So the thing is, today I have questions from EC background. Now let me tell you guys, the number of questions are approximately 40. Okay, 40 to 45 questions are there. So it may be possible that in today's lecture we are not able to complete that. So it may be possible that we have to take part 2 also, part 3 also. Actually it's part 2, because in the previous session I have covered the electrical part. Now it's time for EC part. Okay, so let's start this session, guys. Let's first cover the introduction. This is my introduction. My name is Asu Jangda and I teach almost every subject in electrical engineering. You can start your preparation with me on BYJU'S exam prep. You can join this platform if you want to study from me, and if you want to start your preparation with me. Okay, take shortcut used in full control system session in parallel batch, sir. Okay, I'll take it. Money Kandan. Okay, guys, so this is my Telegram link, and you can join this Telegram group. Link is given in the description also, and you can connect with me on this Telegram. Let me tell you guys, UPSC ESE mains result is out, so you can check your results. If you are selected, you can share your results with us if you are benefited from our classes. Okay guys, so let's start. Let's not delay the session. The first question on your screen is, you can see that consider the system with a transfer function. This is the transfer function. The damping ratio is given as 0.5. Damping ratio is given as 0.5. We need to find the value of K. Tell me guys, what is the value of K if damping ratio is 0.5? Zeta is given as 0.5. What is the value of K? Do it fast everyone. Let's see what is the correct answer. So for that, what you can do is you can take this K first, K common, okay? Because we don't need this K because S square coefficient has to be 1. Na? So if you take this K as coefficient, if you take this K common, then the system will become like this. S square plus 1 by Ks plus 6 by K, okay? This is the transfer function we have. Now from this transfer function, you can say that omega n square is equal to 6 by K, and 2 zeta omega n is 1 by K. Okay, it is given that zeta is 0.5. So from there you can put zeta as 0.5. So this is cancelled. So omega n came out to be 1 by K. And from this relation, you can say that omega n is root 6 by K. Okay. So you got this relation. Now what you can do is you can take square on both sides. If you take square on both sides, 1 by K square is equal to 6 by K. Now what you can do is you can take this, you can cross multiply 6K square minus K equal to 0. So K came out to be 0, 6. There are two values of K. Okay, one is 0 and one is 6. So 0 is not given in the option. Only one option is correct, so answer is Delhi, D. Okay, so K value has to be 6, so that zeta came out to be 0.5. Let's come to the next question. The next question given on your screen is, we have a transfer function. GS is this unit step input to the system. Okay, so this is our system. Transfer function of a system is this. For a unit step input to the system, for this system I am giving unit step input. The approximate settling time for 2% criteria is, okay? So what is the settling time? We need to find that settling time. Okay, now the problem is, in this question it is not mentioned whether this is the overall control system or closed loop control system. Okay, so by default I am taking that this is the open loop transfer function. Okay, now from there you can calculate the closed loop transfer function. So the closed loop transfer function will be 100 divided by s square plus, I'm taking unity feedback, okay, s square plus 101s plus, so GS divided by 1 plus GSHS, okay, so that will be 100 plus 100, 200. I think this is correct. So what I have done is, using this GS, I have calculated the TS value, closed loop transfer function value, okay, closed loop transfer function value. So closed loop transfer function is this, GS divided by 1 plus GSHS. So if you apply 1 plus GSHS, you will get the function like this. Please check my calculation, okay. Now from this transfer function, you can say that omega n is root 200 and zeta omega n came out to be 101 divided by 2. Okay. Now for 2% criteria, we need to calculate the settling time. So tell me guys, what is the formula for settling time? Is it 4 by zeta omega n? Tell me, what is the formula for settling time, everyone? Is it 4 by zeta omega n or 5 by zeta omega n? Because we know the zeta omega n value. If you know the zeta omega n value, what you need to do is, you need to take the inverse of this 1 upon zeta omega n into this factor. Now what is this factor? Is it 4 by zeta omega n or 5 by zeta omega n for 2% criteria? Tell me everyone. Tell me, is it 5 by zeta omega n or 4 by zeta omega n? Okay. Tell me. Is it 4 by zeta omega n, 5 by zeta omega n? So accordingly, you can check. If I revert it, so it will become 2 by 101 into this factor, 4 or 2, 4 or 5, I don't know. Let's take it 5, okay, 5 by zeta omega n. So if you take 5, even you can take even 4 also, it's approximate formula. So 5 by zeta omega n if you do, so it will become 10 divided by 100, 101, approximately 10 by 100. So it will become 0.1, okay. So the answer is almost 0.1 second, but the answer is not given. 0.1 second is not provided. You can see that. Okay, 5 by zeta, roughly for simple calculation, I have taken 5 by zeta omega n. Zeta omega n I have calculated as, because we know that this is 2 zeta omega n. So zeta omega n came out to be 101 divided by 2. Okay. So if I put the value of zeta omega n, it came out to be 10 divided by almost 100. Okay. So it came out to be 0.1. If it is 0.1, but there is no option is matching. So please check this. I mean, there must be some correction in the options. Okay. So please check it. Or there can be correction also. I don't know whether this system is a closed loop transfer function or open loop transfer function, because it is not mentioned here. Okay. So I hope you understood it, how to solve this question. Okay. I have taken settling time as 5 by zeta omega n. Okay. Using 5 by zeta omega n, you can take the approximate answer as 0.1. Okay, let's come to the next question, guys. The next question on your screen is this. The system shown in the figure remains stable when? So, for what value of k the system remains stable? So, what we can do is, from this diagram, we can calculate the transfer function using Meson gain formula. So, let's apply the Meson gain formula. So, tell me guys, how to apply Meson gain formula? For Meson gain formula, mk delta k divided by delta. You apply this formula. Summation k varies from 1 to n. N is number of forward path. So how many forward paths are there? Only one forward path is there. So m1. So what is m1, guys? M1 is k by s. Okay, k by s. And delta. Delta is 1 minus individual loop. Sum of individual loop gain. So it is 3 by s. There is one more individual loop, that is k by s. Okay, k by s. 1 minus sum of individual loop, now plus sum of product of two non-touching loop. There is no non-touching loop. Okay, so if you simplify, it will become s minus 3 plus k by s. This is our delta. Okay, so we found the delta. You can check it. I hope it is clear. 1 minus sum of individual loop gain. So individual loop is this and this. So there are two individual loop. Okay, and now plus sum of product of two non-touching loop. So there are no non-touching loops. Okay, so this is my, you can say, delta. Now what is delta 1? Delta 1 is 1, because this is the first forward path and there is no individual loop which are non-touching to this forward path. Okay, now you can put these values in the formula and you can calculate. So the closed loop transfer function came out to be, tell me the closed loop transfer function. The closed loop transfer function came out to be m1 delta 1 divided by delta. So if you do it like this, you'll get k divided by s minus 3 plus k. Now we know that this has to be, this pole came out to be 3 plus k. It has to be less than 0 because it has to be in the left half of the S-plane. Then only system will be stable. It means k has to be less than minus 3. K has to be less than minus 3. Okay. So D is correct answer. Okay. In the last question, if you apply 4 by zeta omega, na? Okay. If you apply 4 by zeta omega, though the calculation will be bit lengthy, then also you will not get the correct answer. Okay. Let's take 4 by zeta omega. Because for 2% criteria, it's 4 by zeta omega. If you apply 4 by zeta omega, then this is the zeta omega is this value. Okay, so if I put it here, it will become 8 divided by 101. But the answer is not given. That's why I have taken the approximate value. That's why if you take 5, then the calculation part is more easier. But if you do it like this, then also you are not getting the correct answer. It means there must be some correction in the question. Okay. So let's come to the next question, guys. The next question on your screen is this. The characteristic polynomial is given as this. Okay. The system is, we need to find whether the system is stable, unstable, marginally stable or oscillatory. Okay. Now let's apply this. Apply Routh. Okay. So s to the power 5, s to the power 4. Now tell me, guys, 2, then 4, then 2. Okay. Odd power I have written 2, 4 and 2. Odd power. Now even power 1, 2, 1. 1, 2, 1. Now tell me, guys, what is the quotient in S cube? In S cube you have 0 here, okay, and you have 0 here, okay. So you'll get 0. You can see that 4 minus 4 is 0. 2 minus 2 is again 0. So you are getting the entire row as 0. If you get entire row as 0, it means auxiliary equation is this. So s to the power 4 plus 2s square plus 1 is equal to 0. This is our auxiliary equation. Now we know that the roots of the auxiliary equation are also the roots of main equation. Now let's calculate the roots of auxiliary equation. So how to calculate roots of auxiliary equation? You can put s square equal to x. Okay, so if you do it like this, it will become x square plus 2x plus 1 equal to 0. It means x plus 1 square is equal to 0. So x value came out to be minus 1. It means s square value came out to be minus 1. Okay, so I hope you got the point. S square is equal to minus 1. Now at this point x is equal to minus 1, so it means x is s square, no? So there are two roots actually, minus 1 and minus 1. So s square equal to minus 1 and other s square is also minus 1, because actually x has two values, minus 1 and minus 1. Both roots are same. Okay, so s square will also be the same value. Now if you calculate s, it will be plus minus j, and here also plus minus j. So it means from the auxiliary equation you get the 4 poles of the system, and those 4 poles are on the imaginary axis and they are repetitive. You can see that at plus j you have 2 pole, at minus j you have 2 pole. It means the 4 poles are on the imaginary axis. I have solved this auxiliary equation, and using this auxiliary equation I can say that there are 4 poles, and these 4 poles are on the imaginary axis and repetitive poles are there. If repetitive poles are there, then the system will be unstable. Okay, answer is Calcutta. System is unstable. Let's come to the next question, guys. The next question on your screen is this. Which of the following point is not on the root locus of a system with the open loop transfer function? Okay, this is the open loop transfer function. Now we need to find which point doesn't lie on the root locus. We don't know the k value. On the root locus, the magnitude of GSHS has to be 1. And the phase of GSHS has to be plus minus 180, an odd multiple of 180. Okay, plus minus odd multiple. These are the Ivan conditions. Now we cannot check this criteria. Why? Because k is unknown. That's why. You cannot calculate the magnitude. So what we can do is we can calculate the phase. So the phase of this function, if you put s equal to these values, okay. Now what is the phase of this function? Let's calculate the phase. So first of all, if you take this value, maybe not this value, let's take this value and let's see whether at this value the phase become odd multiple of 180 or not. So what you can do is you can take this k value, I'm assuming k is positive, and you put this value. So if you put this value, it will become minus 1.5 into minus 0.5 into plus 1.5. So now you can see that there are two negative values. So the product of two negative values will become positive. So this quantity is positive. It means the phase has to be 0. Because the 180 phase came out to be if this quantity become negative. So this cannot be on the root locus. This is not satisfying the phase criteria. Now let's come to this point. At this point also you can see that if you put this point at s equal to minus 3, if you put, okay. So s equal to minus 3 will lie on the root locus. We know that because it's the pole of GSHS. So root locus will start from this point, minus 3 point. Okay, minus 1, minus 2, minus 3. Since at minus 3 you have one pole. One pole is at this point, one pole is at this point, and one pole is at this point. So minus 3 will be on the root locus. Now he is asking which point is not on the root locus. So minus 1.5 is not on the root locus. You can see that minus 1.5, because at minus 1.5 phase criteria is not satisfied. So there is no need to check this point or this point. Okay, so it means Bombay is the correct answer because not on the root locus is asked. Okay, so we have calculated that minus 1.5 cannot be on the root locus because it is not satisfying this Ivan condition. And luckily it is asked which of the point is not on the root locus. So this point is not on the root locus. Okay, even you can draw the root locus and you can see the real part of the root locus, and you can see whether this real point or real point lies on the root locus. So this point will lie on the root locus, but this point will not lie on the root locus. So only one answer is correct. That's why there is no need to check this point or this point. Okay, let's come to the next question, guys. The next question on your screen is this. A Nyquist plot of all pole second order open loop system is shown in the figure. So we have an all pole open loop system and its Nyquist plot is shown in the figure. Obtain the transfer function. Actually it's a polar plot. So polar plot is given. Now we need to find the transfer function. How to find the transfer function from this graph? Tell me, guys, how to find the transfer function of this graph? So the transfer function can be calculated very easily. Let's assume that the transfer function is k divided by s plus alpha into s plus beta, because it's an all pole system and it's a second order system. That's why I have taken two poles. Okay, I have not taken any pole at origin. The problem is because we know that when omega is 0, the magnitude of this function has to be 2. It means if you put omega equal to 0, then the magnitude of this function will become k divided by alpha into beta. This has to be 2. Okay, it is given from this point. You can say that at omega equal to 0, if you put omega equal to 0, then s will become 0. Na? Then this magnitude came out to be 2. Okay. Now we know that at omega equal to 2, the phase is minus 180, phase is minus pi by 2, and the magnitude is 2. So if you put omega equal to 2, it means in place of this s, if you put s equal to j2, okay, then the magnitude will become k divided by root of alpha square plus 4 into beta square plus 4. Okay, this is the magnitude we have when s equal to j2. This is the magnitude we have, and this magnitude has to be 2. This length you can see that it's 2. So this magnitude has to be 2 when s equal to j2. When s equal to j2. Now let's also calculate the phase of this. When s equal to j2, what is the phase? Then the phase will be tan inverse of minus tan inverse of 2 by alpha minus tan inverse of 2 by beta. Okay, this phase came out to be minus pi by 2. Minus pi by 2, because we know that at omega equal to 2, the phase has to be minus pi by 2. Okay, so I have written like this. Now if you simplify this, you can take this minus out, okay, it will become plus. And if you add these tan inverse quantity, then what will you get? Tell me guys. Tan inverse of A plus tan inverse of B. So it will become tan inverse of A plus B divide by, wait a minute, it's not whole divide, okay. Tan inverse of A plus B divide by 1 minus AB, okay. Tan inverse of A plus B divided by 1 minus AB, it has to be pi by 2. Now when will it become pi by 2? When this product become 0, when this denominator becomes 0. So tan inverse of something upon 0 will become pi by 2. It means this 4 by zeta, 4 by alpha beta has to be 1. Okay, it means the alpha beta has to be 4. From there you can calculate alpha beta has to be 4, and if you put alpha beta 4 here, then k came out to be 8. So we found the value of k. K came out to be 8, and alpha beta, the product of these pole location, has to be 4. So this k is 8 and the product of these two is 4. Now what we want is, we want alpha and beta separately. So from this relation you can calculate the other 2 points, I mean the alpha and beta. We know that k is 8, so you can put k value as 8. Okay, so now from this relation you can write as root of alpha square plus 4 into beta square plus 4, that is came out to be 8 divided by 2, 4. Now what we can do is, we can take the square on both sides. If you take the square on both sides, then you can say that it will become alpha square plus 4 into beta square plus 4, that came out to be 16. Now if you multiply it, you will get alpha square beta square plus 4 into alpha square plus beta square plus 16 is equal to 16. Now this is gone, and alpha square beta square, what is alpha beta? Alpha beta is 4, so alpha square beta square is 16. Okay, so from this relation you can say that alpha square plus beta square is equal to minus 4. Wait a minute, it cannot be negative. Okay, so please check where I did mistake. It cannot be, wait a minute, so if you take square on both sides you will get this, okay, and if you multiply alpha square plus beta square plus 4 times of alpha square plus beta square, and this is also 16, this is all okay, this is gone. Now alpha square beta square, now alpha square beta square you can take as, tell me guys, it's 16. So alpha square plus beta square came out to be minus 4. It cannot be possible guys. It cannot be possible. It is possible only if alpha and beta both are imaginary. If both are imaginary, okay, if both are imaginary, or it is possible if one is imaginary, then also it is possible. Okay, alpha square plus beta square, because the roots are not real. You can say that the roots are not real. If the roots are not real, or one root is real, one root is purely imaginary, then also it came out to be negative, na? Okay, so this is possible only if one root is real and one root is imaginary. But the problem is, both the root has to be real. Why? How can you say that? Because you know that when omega is 0, then the angle has to be 2. Now there must be some mistake. Please check where I did mistake. So this is the transfer function I have written, and when omega is 0, the magnitude has to be 2 and angle has to be 0. Angle has to be 0. So what is the magnitude when omega is 0? When omega, if you put omega equal to 0, then the magnitude will become k divided by alpha beta. It is 2, it is given. Now when omega is 2, angle came out to be minus pi by 2. Angle came out to be minus pi by 2. So what I did is, I calculated the angle, that is tan inverse of, I have put s equal to j2 because omega equal to 2 na. So I put s equal to j2. So angle is minus tan inverse of 2 by alpha, okay, minus tan inverse of 2 by beta. That came out to be minus pi by 2. I have cancelled this minus and I have added this. Tan inverse of a plus tan inverse of b is tan inverse of a plus b divided by 1 minus ab. Okay, and that came out to be pi by 2. Pi by 2 means 90. This will become 90 only if denominator becomes 0. It means the product of alpha and beta has to be, now we can see that the 4 upon alpha beta has to be 1. It means alpha beta has to be 4. So if alpha beta is 4, if you calculate alpha beta equal to 4, you can put it here, alpha beta equal to 4, and k came out to be 8. Okay. So we have calculated that k is 8. Now once you get this k value, how to calculate alpha and beta now? At this point, at omega equal to 2, the magnitude is 2. You can see that the distance from the origin is 2. Okay. So if you put s equal to j2, and if you calculate the magnitude, then the magnitude will become k divided by root of alpha square plus this imaginary part square, 2 square, that is 4, into beta square plus 4, and this magnitude has to be 2. Okay. So what I did is I put k as 8. Okay. So if you put k as 8, then take this 2 in the denominator, so it will become 4. 4 has to be equal to this. Now if you take square on both sides, then what you will get? You will get alpha square plus 4 into beta square plus 4 has to be equal to 16. Okay. Now if you multiply alpha square beta square plus 4 times of alpha square plus beta square plus 16 has to be equal to 16. Now this is cancelled. So from there you can put this alpha beta value. Okay, you can put this alpha beta value. Okay, and if you put this alpha beta value, alpha beta is 4, so it will become 16. Now this alpha square plus beta square came out to be minus 4. Now this is the problem, guys. I think in this system there is something correction is required. Okay, all poles second order system, open loop system is shown. Obtain the transfer function of the system. We are doing correctly. I think there is no mistake. Please check whether there is some mistake or not. I don't think there is a mistake, because at omega equal to 2 you are getting minus pi by 2. So at omega equal to j2 I have calculated the angle, that is minus pi by 2. Everything is correct. Okay, so please check this question. There must be some correction. Okay, there must be some correction, guys. There, because alpha square plus beta square is negative, it means alpha beta cannot be real. Alpha and beta cannot be real. Okay, alpha and beta cannot be real. Either both are imaginary, or it may be possible that one is real, one is imaginary. Okay, so it cannot be possible that one is real, one is imaginary, because the product is 4, na? So both has to be imaginary. Both has to be imaginary, then only the product will be real. Okay, so it doesn't matter. Let's solve further. Okay, so we have found that alpha beta is 4 and alpha square plus beta square equal to minus 4. Now what you can do is, from here you can calculate alpha. Alpha came out to be 4 by beta. Okay, and now you can put this alpha value here. If you put this alpha value here, it will become 16 by beta square plus beta square is equal to minus 4. Okay, now from here you can see that beta to the power 4 plus 4 beta square plus 16 is equal to 0. Okay, so this is our relation in beta. Okay, now what you can do is you can put beta as x. So if you put beta as x, then you can see that it will become x square plus 4x plus 16. That is equal to 0. Now I have to calculate the roots of, the value of beta. Similarly, you can calculate the value of alpha. So alpha and beta you can calculate from here. It may be possible that they can be conjugate of one another. Okay, so alpha and beta you can calculate from here. You can put those alpha beta here and calculate the transfer function. Now the next part is yours. The next calculation is yours. You have to calculate that. Okay, so next calculation you have to do. So we have calculated that alpha beta came out to be 4 and alpha square plus beta came out to be this. There is one more way to calculate that. We know the product of the roots. We can also calculate the sum of the roots, because we know that the transfer function has to be k divided by s square plus alpha plus beta into s plus alpha beta. Okay, this is the transfer function. So if you know this alpha beta is 4, can we calculate this alpha plus beta? I think we can calculate alpha plus beta. How to calculate alpha plus beta? Alpha square plus beta square is this. Now we know that, let's calculate alpha plus beta. How to calculate alpha plus beta? No, we cannot calculate from this. So ultimately we have to solve this equation. Okay, we know that alpha square plus beta square is minus 4. Now from here you can calculate beta in terms of alpha or alpha in terms of beta. You can put that alpha value here and calculate the beta value. It may be complex. Okay. Once you get this beta value, then you will also get the alpha value, and you can put it here and calculate the transfer function. So it's a lengthy problem. Okay. That's why it's a 5 marks question. So in 2002, subjective questions are also there. So you can easily calculate like this. You should understand the concept. So concept is very easy. From this graph, we can calculate the transfer function. Let's come to the next question, guys. The next question on your screen is this. The phase margin of the system with the open loop. So for this system, I need to calculate the phase margin. How to calculate phase margin? To calculate the phase margin, first you need to calculate the gain crossover frequency. Okay. So what is the gain crossover frequency? To calculate the gain crossover, I need to put S equal to j omega, and the magnitude has to be 1. At what frequency the magnitude will become 1? So if you put S equal to j omega, it will become like this. It will become like this. And we know that at phase, we know that the magnitude is become at omega equal to omega gc. At gain crossover frequency, this magnitude has to be 1. Let's calculate this magnitude. So the magnitude will become 1 by, it is 1 plus omega square, and the magnitude of this function is also 1 plus omega square. So this will cancel. Now it will become 4 plus omega square. This is the magnitude, and this magnitude has to be 1. Now from this relation, you can see that, you can say that 4 plus omega square has to be equal to 1. I have taken square on both sides, and so omega square came out to be minus 3, omega came out to be j root 3. Okay. So at omega equal to root 3, you can say, at omega equal to root 3, you can say that this omega has to be positive. No? Okay. It means there is no frequency at which the magnitude, there is no real frequency, because this omega has to be positive value. Omega square has to be positive value. There is no real frequency at which the magnitude is becoming 1. You can see that. Okay. So there is no real frequency from 0 to infinity. There is no such frequency at which this magnitude become 1. Okay. It means omega gc doesn't exist. Omega gc not exist. So there is no frequency at which the magnitude become 1. That's why you cannot calculate omega gc. If you cannot calculate omega gc, you cannot calculate the phase margin. Phase margin has to be infinite, you can say. Okay. Phase margin has to be infinite. Why infinite? Because margin is always there. No? It can be infinite. You can increase frequency up to infinite. This system, the angle of this transfer function will never be, you can say, it will never be become 180. It will always be, I mean, why I am saying this infinite? Because we know that the phase margin can be calculated with the help of omega gc. If omega gc exists, then only you can calculate the phase margin. Okay. So it is not existing. Omega gc is not existing. That's why it has to be infinite, you can say. Phase margin is infinite. Let's come to the next question, guys. The next question on your screen is the system with open loop transfer function. We need to calculate the gain margin. To calculate the gain margin, what we need is we need omega pc, phase crossover frequency. Omega pc. How to calculate omega pc? To calculate omega pc, we require the phase of this system, and the phase has to be minus 180. The frequency at which the phase become minus 180 is known as phase crossover frequency. Once you calculate the phase crossover frequency, then you can calculate the gain margin. At that frequency, you have to calculate the magnitude, okay, A, and then you can apply 20 log 1 by A. This is our gain margin. Okay, this is our gain margin. Okay, so let's calculate omega pc first. So to calculate omega pc, you put s equal to j omega, so it will be minus 90 minus 10 inverse of, tell me guys, omega divided by 1 minus omega square. So this is the phase. This is the phase of this function. Now let me tell you guys, it's very interesting, because if you replace s equal to j omega, then it will become like this: j omega minus omega square plus j omega plus 1. This is our transfer function. Now the angle of this quantity is 90, so in the numerator we will write minus 90, and the angle of this quantity is tan inverse of imaginary part by real part, and we have taken the minus sign here. But let me tell you guys, this phase is correct only if omega is less than 1. Why? If omega is less than 1, then or obviously greater than 0. 0 to 1, this phase is correct. This phase expression is correct only if omega is between 0 and 1. Why so? Because we know that if omega is between 0 and 1, then this complex number will lie in the first quadrant. And the first quadrant, the angle is tan inverse of imaginary part by real part, and you can directly solve like this. But if omega is greater than 1, then you can see that this real part become negative. Let's say omega is 2. If you put omega equal to 2, this will become minus 4, this will become plus 1. So minus 4 plus 1 is minus 3, and this is plus j2. So you can see that the real part become negative and the imaginary part is positive. It will become in second quadrant. So the net phase of this function for omega greater than 1 is minus 90 minus 180 minus tan inverse of omega divided by 1 minus omega. Now I have to write omega square minus 1 now. Okay, omega square minus 1, because I had to write the positive value. Since omega is greater than 1, so omega square minus 1 is the positive value. So this is the new phase for omega greater than 1. If omega is greater than 1, I have to use this phase criteria, and if omega is less than 1, this phase I have to use. Obviously, if you solve it, it will become minus 270 minus tan inverse of omega divided by omega square minus 1. Okay, and this is the phase. Now you can easily see that if I increase the value of omega, then this angle will become more negative. Wait a minute. Okay, it has to be plus. Okay, now if you increase the value of omega, you can see that this angle is changing and this angle is also changing. Now let's calculate omega PC. How to calculate omega PC? To calculate omega PC, I have to put this phase, either this phase or this phase, equal to minus 180, and let's calculate the frequency. So if I put this angle equal to minus 180 to calculate omega PC, okay, I have to put this angle equal to minus 80 and this angle also equal to minus 80. Let's calculate the omega. Now from this expression, you can easily calculate omega, that omega has to be in this range. If it is not in this range, it means this calculation is wrong. You can calculate from this expression. So let's calculate. From this expression, you can see that minus 90 will come on this side. So you can say tan inverse of omega divided by 1 minus omega square came out to be 90. And this will be 90 if omega is equal to 1. At omega equal to 1, it came out to be 90. And omega equal to 1, you can say that it lies in this range. Similarly, here also, you can take this omega equal, because omega equal to 1, if you put omega equal to 1 in this expression, then also it is becoming minus 180. It means omega PC has to be 1. Either you calculate from this expression or this expression. If you put equal to minus 180, you will get omega equal to 1 from this expression also. Okay, so omega equal to 1 is my omega PC. That's correct. Now, once you get this omega PC, how to calculate the gain margin? Now you have to calculate the magnitude. So what is the magnitude of this function? Let's calculate the magnitude. 1 divided by omega root of, tell me guys, root of omega square plus 1 minus omega square whole square. Okay, this is the magnitude, guys. What is this magnitude? At omega equal to 1, let's calculate the magnitude. This is gone, this will become 1. Omega equal to 1, this is 0, and this is 1, this is also 1. So magnitude become equal to 1. The magnitude is 1. Okay, and this magnitude we call A. So this A is equal to 1. A equal to 1. So if you put 20 log 1 by 1, you will get 0 answer. It means the answer is 0 dB. Answer is Bombay. Okay, so the gain margin is 0 dB. I hope it is clear. Let's come to the next question, guys. The next question on your screen is this. We have the transfer function ys upon us of a system described by the equation. So we have this state equation, x dot t is equal to minus 2xt plus 2ut. Okay, this is state equation and this is output equation. We need to find the transfer function. So how to calculate the transfer function? Easily you can take the Laplace transform and you can calculate the transfer function. Let's take Laplace on both sides. So sxs, while taking transfer function, we take initial condition to be 0. So I am not writing x0. Sxs is equal to minus 2xs plus 2us. Okay, I can write it like this. Now take this xs on this side, so it will become s plus 2 into xs is equal to 2us. Okay, and from this equation you can say that ys equal to 1 by 2 xs. Ys equal to 1 by 2 xs. Okay, it means xs has to be 2ys, so you can put this xs as 2ys. 2 into s plus 2 into ys is equal to 2us. You can write it like this, and 2 is gone. So now from here you can calculate ys upon us, that is equal to 1 over s plus 2. So answer is Delhi. Okay, answer is Delhi. This was very simple question. You can easily calculate by taking Laplace transform. Let's come to the next question, guys. The next question is the step responses of a set of 3 second order underdamped system all have the same percentage overshoot. They have the same percentage overshoot. Okay, it means e to the power minus pi zeta divided by root of 1 minus zeta square. They have the same value. This is same. It means zeta is same. Okay, zeta is same because they have same percentage overshoot. It means this zeta value has to be same. Okay, which of the following diagram represent the poles of 3 system? Zeta same means cos phi same. Cos phi is same for 3 system. It means phi is same for 3 system. Phi is same for the 3 system. It means the pole should lie such that the angle phi should remain same. You can see that they all are lying at the same angle phi. Okay, so let's see. So C is correct answer, guys, because at C you can see that this angle phi is same, so zeta is same, and if zeta is same, then the percentage overshoot will also remain same. So answer is Calcutta. Let's come to the next question. The next question on your screen is this. Let's come to the next question, guys, and tell me what is the correct answer for the next question. Wait a minute. Yeah, tell me, guys, what is the correct answer for the next question. The next question on your screen is, we have the system PQRS and we have their responses. We have their step responses. Okay, match the step responses. So first look at this. This is an oscillatory system. If this is an oscillatory system, then the output will be like this. Oscillatory. Okay, so you can say that for the P, answer is 1. Answer is 1. Answer is 3. Okay, so for P, answer is 3. Either A is correct, or B is correct, or D is correct. C is wrong. Now let's come to this. Now in this system, or better you look at R first. R. Look at this. This is critically damped system. This is critically damped system because you can see that it's s plus 6 whole square. Both the roots are at the same position. The denominator, s plus 6 whole square. Okay, both the roots are at the same location. It means it's a critically damped system. Okay, so for the critically damped system, the response will be like this or this. Okay, actually it is for over damped, you can say. For critically damped, the response will be more or less like this. It means you can say that R has to be 1. R has to be 1. So R has to be 1. So in this option, you are getting R equal to 1. So it means D has to be correct answer. But I am not sure, because I think yes, it's because if this is critically damped, then only it will become over damped. Okay, so you cannot take this as critically damped. You have to take this as critically damped. Then the downward will become over damped. Okay, so R has to be 1. Now you can also see that if you look at this. If you look at this, B square minus 4 times of 36. Okay. Now it is positive. It is positive, you can see that. If it is positive, it is over damped and it is critically damped. It is critically damped. For this system, S system, the response is 2. For critically damped, for underdamped, this is underdamped. No? This is underdamped. Okay, because discriminant is less than 0. So B square minus 4AC. So it is underdamped, and for underdamped system, this is the response. It means for S you have 2. For S you have 2. For S you have 2. Okay, and since it is overdamped, this is overdamped because discriminant is positive, so it is overdamped, and this is the response for overdamped. So answer is 4. It means for Q you have 4. For Q you have 4. So answer is Delhi. D is correct answer, guys. Let's come to the next question. The next question on your screen is this. A certain system has transfer function. This is our GS. GS is given to us, where alpha is a parameter. Where alpha is a parameter. This alpha is some parameter. Consider the standard negative unity feedback configuration. Okay, we have to consider negative feedback. Which of the following statement is true? Which statement is true about this? The closed loop system is never stable for any value of alpha. Okay, so it means all the options are about stability. For some positive value of alpha, the closed loop system is stable. It means for stability, we need to find whether this system is stable or unstable for particular value of alpha or not. So what you can do is, we can calculate its closed loop transfer function and we can apply Routh, and we can check whether for some particular value of alpha or some range of alpha, whether the system is stable or unstable. Okay, so let's calculate. Let's apply the Routh. But before applying Routh, let's calculate the characteristic equation. So characteristic equation you can calculate by taking GS divided by 1 plus GSS. Okay, the denominator of closed loop transfer function is characteristic equation now, and the closed loop transfer function is GS divided by 1 plus GSS. So if you apply GS divided by 1 plus GSS, then the characteristic equation I am writing directly, because you don't need to write every step, you know that. Okay, so it will become S, and then it will become 4. This is our characteristic equation, guys. Put it equal to 0. GS divided by 1 plus GSS. I have done like this. GS divided by 1 plus GSS, and then I have looked the denominators, and the denominator will become like this: S square plus alpha plus 1S plus 4. Now you can apply Routh. There is no need to apply Routh also. I mean, but you can apply Routh if you want. Okay, so it is 1, 4. This is alpha plus 1, and now S to the power 0 is 4. Now tell me, when this system will be stable? When this is positive, it means alpha plus 1 has to be positive, alpha has to be greater than minus 1. If alpha is greater than minus 1, then only this system, this closed loop system will be stable. Okay, so let's see. The closed loop system is never stable for any value of alpha. This is wrong. For some positive value of alpha, the closed loop system is stable, but not for all positive value. No, this is not correct. System is stable for all positive value of alpha, because positive value of alpha means greater than minus 1 values. Okay, greater than minus 1 is positive range, na? Some negative and all entire positive. But this system, this answer is wrong, because he is saying that for some value of positive value of alpha, it is stable. For all value of positive value, it is stable. We know that. Okay, for all positive value of alpha, closed loop system is stable. That's correct. Okay, that's correct. Because if alpha is greater than minus 1, it contains all positive value also, na? Okay, now the closed loop system is stable for all value, both positive and negative. This is wrong. Okay, so answer is Calcutta. Let's come to the next question, guys. The next question is the number of open loop right half plane poles. Okay, so open loop, this is the open loop system. How many poles are in the right half of the S plane? You can directly apply Routh. Okay, you can directly apply Routh, and you can see how many poles are in the right half of the S plane. I think it's easy peasy. You can easily solve it. Okay, I'm not solving this. You can easily solve this question. Okay, Routh we have applied so many times, so easy peasy. Let's come to this question. The pole 0 plot given below correspond to, so which filter this pole 0 plot is representing? Now let's give them some number. Let's say this is -2, this is -3. It means GSHS, or the transfer function, whatever transfer function whose pole 0 is given, that transfer function will look like this: K divided by S plus 2 into S plus 3. You can also write it like this: some constant K naught divided by S by 2 plus 1 into S by 3 plus 1. Now if you draw its Bode plot, then the Bode plot will look like this. This is 2, this is 3. So it will look like this. Okay, this is 20 log K naught. 20 log K naught. At 2, there is a first down, -20 dB per decade. At 3, there is one more down, -40 dB per decade. So this is the Bode plot. Okay, now you can easily see that it's kind of low pass filter. Okay, it's kind of low pass filter. Obviously this value has to be greater than 1, then only we call it low pass filter. So by default we can take it greater than 1. So the proper answer is it has to be a low pass filter. Okay, it's kind of a low pass filter. Okay guys, so easily you can draw its Bode plot, and from the Bode plot you can see that at lower frequency it has higher gain, at higher frequency it has lower gain. Okay, that's why it's a low pass filter. Now guys, you can join our test series. Okay, and test series is also available on our mobile app, so you have to install our mobile app. You can install and you can give the test series on the mobile app, and you can check your score whether you have prepared well or not. Okay, let's come to the next question, guys. The next question: the frequency response magnitude of a underdamped second order system is 5 at 0 radian per second. Okay, at 0 radian per second, the magnitude is given as 5, and at 5 root 2, the peak is there. 10 by root 3 is the peak value. We know that the frequency response of a second order system is like this. Okay, so at this frequency, we call it resonance frequency. You are getting the peak value, and the peak value is 10 by root 3. And at omega equal to 0, this magnitude has to be 5. Now, which options are correct? Now, you can see that at omega equal to 0, this is also giving 5. This will also give you 5. At omega equal to 0, I think this is also giving you 5. Okay. Yes. Now, what about this? This is also giving you 5, I think. Yes, it is also giving you 5. At omega equal to 0, all the systems are giving you 5 value. Now, this is my resonance frequency. And what is the formula for resonance frequency? Resonance frequency is omega n root of 1 minus 2 zeta square. Okay. This has to be 5 root 2. This has to be 5 root 2. And this is our resonant peak. This is our resonant peak. So you can apply the resonant peak formula. Okay. And this is our resonance frequency. So now you can check which option is satisfying this. Let's say the first option. In the first option, omega n came out to be 10 and zeta came out to be 1 by 2. So if I apply this formula, if I put these values, 10 root of 1 minus 2 by 4. Okay. So you can easily see that it will become 10 root 1 by 2. Okay. So it will become 5 root 2. It will become 5 root 2. It means it is satisfying this condition. Resonance frequency of this function is this 5 root 2. What about this function? What about this function? If you calculate omega n is root 75. Okay. And we know that this is 2 zeta omega n. So zeta you can calculate from here. Zeta will be equal to 5 by 2 root 75. So it will become 5 by 2 root 3. 5 by 2 root 3 because 75 is 25 into 3. So 25 root is 5, so it will be cancelled. So this is my omega n. This is my omega n and this is my zeta. This is my omega n and this is our zeta. So if I put it here, then you can easily see that it is root 75 into a root of 1 minus 2 zeta square. Zeta square is this. So it will become 25 divided by 4 into 75. Okay, so it will become 1 by 6. So root 75 into root of 1 minus 1 by 6. You are getting this value. Is it equal to 5 root 2? Is it equal to 5 root 2? Let's calculate this. So it will become root 75 into root 5 by root 6. And root 6 can be written as root 2 into root 3. And this 75 is 5 root 3. Okay, 5 root 3. So this root 3 is gone. Okay, so it will become 5 root 5 by 2. It is not 5 root 2. So this is wrong. So similarly, you can check. I think A is correct. Okay. Yeah, peak overshoot. You can no, it's not peak overshoot. It's called resonant peak. From resonant peak, you can calculate zeta value. Okay. From there also you can calculate. Okay. You can apply the formula for resonant peak and you can check. I think A is correct answer because no other option is satisfying this, even this relation or zeta value. Okay. Because from here you can calculate the zeta and you can check which option is satisfying for zeta. I think A is correct. You can check it yourself. Okay. Let's come to the next question, guys. The next question on your screen is this. Group 1 gives two possible choices of impedance Z in the diagram. Okay. So there is group 1 Okay, this is group. Oh, okay, this is some diagram, and P. Okay, wait. This is Q. This is R. Okay, Q and R. So group 2 is this. Group 1 is this. I don't know what's the question. Group 1 gives two possible choices of the impedance Z in the diagram. The circuit element in Z satisfy the condition R2C2 is greater than R1C1. R2C2. Okay, R2C2 is greater than R1C1. Okay, this product R1C1. Now, the transfer function V0 by Vi represent the kind of controller. Match the impedance in group 1 with the type of controller in group 2. Okay. So this is our group 1. This is our group 1, and group 2 is about controller. Okay. So we need to tell that this Q is representing Q1. Q1 means PID controller. Okay. Okay. This is okay. This we need to check if I replace this Z with Q, whether this represent PID controller, lead compensator, or lag compensator. That I need to check. Okay. So how to check it, guys? It's very simple. With the help of transfer function, you can do it. So what we can do is, let's replace this Z with R2C2. If you replace this Z with R2C2, R2 and C2, let's calculate the transfer function. First, we know that this is 0, so this point has to be 0. Okay, now this is VIS. So let's first combine them in Laplace domain. This is 1 by C1s, this is R1. So what is the impedance of this? Because they are in parallel. So we can take the impedance. So impedance is R1 into 1 by C1s divided by R1 plus 1 by C1s. So if I take the LCM, it will become R1 divided by R1 C1s plus 1. Okay, this is this impedance, guys. So we have found this impedance, and we know that this voltage is 0. This is VIS. So what is the current? How much current will flow from VIS to 0? So that is this VIS divided by the total impedance. So the current is VIS divided by R1 C1s plus 1 into R1. This is the amount of current which is flowing from this. Now that same amount of current will flow through this. So if you calculate this voltage, then this current into R2 plus 1 by C2s. Okay, you just simply multiply it. This is this voltage. Now we know that this voltage is 0. 0 minus this voltage will be V0s. So V0s is equal to 0 minus this voltage will be my V0s. So from there you can calculate V0s over VIS. V0s over VIS is equal to, you can calculate V0s over VIS, that is equal to R1 into R2 C2s plus 1 divided by R1 C1s plus 1 into C2s. Okay, into C2s. This is our transfer function, guys. This is our transfer function. Now let's see whether it is some controller or some compensator. We need to check that. So for that, what we can do is we can take its angle. It's not some kind of compensator. You can see that not some kind of controller, because in PID controller, generally we have in the denominator, PID controller is like this, na? Kp plus Ki by S plus Kd S. It means in PID controller there are two zeros and one pole, but it is not like that. So it's kind of compensator. Okay, but which compensator? So let's calculate the angle to find the compensator. This angle will be 90. So in the numerator you have to take minus 90. What about this angle? This angle is tan inverse of R2C2 by R2C2 omega by 1. Okay, you can put S equal to J omega. Now what is the angle of this? Minus tan inverse of R1C1 omega by 1. Okay, this is the angle of this function. Or what you can do is let's it's like this only. Now you can see that it is given that R2C2 is always greater than R1C1. It means this angle will always be greater than this angle. So this is always positive. This will always be positive. This will always be positive. But this is minus 90. This sum cannot be 90. It is always less than 90. It is positive but always less than 90. Minus 90 is this. So this angle came out to be negative. This angle will always be negative. This angle will always be negative. It is positive, it is negative, but this sum can never be plus 90. It will always be less than plus 90. It is positive, we know that, because this is always greater than this value. So this angle will always be greater than this value. But let me tell you guys, this angle, this total sum cannot be 90. It will always be less than 90, but it is positive. This is minus 90. So if you sum them, it will always be negative. If it is negative, it means it's a lag compensator. So it represents a lag compensator. It means this Q has to be a lag compensator. Q has to be 3. Q has to be 3. Okay. It's a lag compensator. So with the help of this only you get the correct answer. Okay. Q has to be lag compensator. Please check my calculation. I think I have done it correctly. Okay. Now please check my calculation. If calculation mistake is there, please excuse me for that. Okay, let's come to the next question, guys. The next question on your screen is this. The signal flow graph of a system is given below. This is the signal flow graph. Now, the set of equation that correspond to signal flow graph, it means we need to write the state equation. But the state variables are not mentioned in the problem. We don't know where x1 is and where x2 is, where x3 is. Now you can see that this is 1 by s. So if you take x1 here and then this is x1 dot, but it is not mentioned. You can take x2 here, this will become x2 dot. You can take x3 here, this will become x3 dot. You can take x4 here, this will become x4 dot. So we don't know where x1, x2, x3 are. If x1, x2, x3 position is not known to us, we cannot solve this problem. Okay, so please check whether where the x1, x2, x3 are given. If it is not given, if it is not mentioned, you cannot tell. You cannot tell which option is correct. Okay, so that's, I mean, then you have to apply permutation combination. First you take x1 here, x2 here and x3 here. Then you take x2 here, x1 here, x3 here. I mean, you have to change the location and then you have to see which option is correct. So that's the difficulty in this problem. So I think there is a correction in this question. x1, x2 should be mentioned. It is not mentioned in the problem. That's why we will not be able to find the solution exactly. Okay. So please check whether there is a correction or not in this problem. Okay. If there is some correction, tell me. Okay. But otherwise, we will not be able to solve it. So remember this question. Okay. x1, x2, x3 should be mentioned. Then only you can solve the problem. Okay. Let's come to the next question, guys. The next question is some p matrix is given. We need to calculate e to the power p. Okay. E to the power p we need to calculate. So how to calculate? So from p we can calculate e to the power pt and then put t equal to 1. So how to calculate e to the power pt? Using Laplace transform. It's very easy. State transition matrix. But before solving this, there is one way. Using the option you can check the answer. Okay. Let's apply. Let's put the t value here. Okay. Let's put the t value here. This will become e to the power at. Here also you can put the value of t. This will become e to the power at. Okay, now we know that in e to the power at t equal to 0, it has to be identity matrix. Now you can see that at t equal to 0, it is not becoming identity. At t equal to 0, it is 1. This is also 1. It is not becoming identity. Now, let's come to this. At t equal to 0, it is becoming minus 1. You can see that at t equal to 0, it is 1, it is 2 and it is minus 3. So it is becoming minus 1. It's again not correct. Let's come to this. At t equal to 0, you can put t equal to 0 in this. It is not becoming 1. It's not becoming identity. But if you look at this, at t equal to 0, you can see that at t equal to 0, it is becoming 1. 2 minus 1 is 1. It means it is approaching identity. This is also, you can see that tt. At t equal to 0, it is becoming 0. It is also becoming 0. It is also becoming 1. So answer is Delhi. There is no need to find e to the power. There is no need to apply Laplace transform on that. You can directly calculate from there. Let's come to the next question. So some block diagram is given to us and we need to calculate what is the transfer, which option is correct. Okay. which option is correct in this question. So what you can do is, it's a very simple question. First you solve this block diagram. So if you solve it, it will become Z1 divided by 1 plus Z1 H1. Okay, so this is one block and there is one cascade Z2. Okay, there is one cascade Z2 and there is unity feedback now. There is unity feedback. Okay, so now you can combine them. It will become Z1 Z2 divided by 1 plus Z1 H1. Okay, this is our overall system. Okay, and there is a feedback. There is a unity feedback. There is a unity feedback. So now you can further simplify it. So the overall closed loop system will become Z1 Z2 divided by 1 plus Z1 H1 plus G1 G2. Okay, you will get this. If you simplify this, you will get this. So let's check. G1 G2 divide by 1 plus Z1 H1, 1 plus G1 H1 plus G1 G2. I think Bombay is correct answer. Okay, I think Bombay is correct answer. So this was simple question. Let's come to the next question, guys. The next question, the open loop transfer function of a unity feedback control system is given by this. Okay, so given that the feedback is unity and this is my GS, the peak overshoot of the closed loop system to a unit step input be 10%. What is the value of K? Let's first calculate closed loop system. The closed loop system will become K divided by S square plus 2S plus K. Okay, this is our closed loop system. GS divided by 1 plus GSS. Now from this closed loop system, omega n came out to be root K and zeta came out to be 1 by root K. Zeta came out to be 1 by root K. Now it is given that the percentage overshoot is 10%. It means e to the power minus pi zeta divided by root of 1 minus zeta square is 0.1. I have divided with 100. Okay, and zeta is given as 1 by root K. So what I can do is I can take ln on both sides. So or you can put zeta as 1 by root K. First you take ln. Okay, first you take ln on both sides. So if you take ln on both sides, then it will become minus pi zeta divided by root of 1 minus zeta square is equal to ln 0.1. Fine. And you can put this zeta as 1 by root K. So it will become minus pi by root K into, this will become root K divided by root of K minus 1. Okay. This root K is gone and it is ln 0.1. Now from here you can calculate the K value, guys. I don't have the calculator, but you can calculate from here what is the value of K. Okay. So it's again easy peasy and you can solve it easily. Let's come to the next question. Now you have to solve it. Okay. It's a simple question. Let's come to the next question, guys. The response of a system GS is given as this. This is our GS. Okay. To the unit step input UT is YT. Okay. He is saying that for this system, if you put step input, then the response is YT. The value of dyt by dt at t equal to 0. It means what is this value at t equal to 0? So what you can do is, let's calculate this dyt by dt. Dyt by dt in Laplace domain will become SYS. If you apply Laplace property, this will become SYS. It means it will be equal to S into S minus 2, because what I'm doing is I am putting this YS. YS is GS into 1 by S. This is YS, no? Because this is the system and the input is UT. In Laplace domain, it's 1 by S. So what is YS? YS is this GS, S minus 2 divided by S plus 2 into S plus 3 into S. This is my GS into 1 by S. So this is my YS. If I multiply it with S, it will become SYS. Okay? SYS in time domain is d by dt. So the d by dt in Laplace domain is this. We need to find its initial value. So what you can do is, we can apply the initial value theorem. Okay? So we can multiply it with S. We can multiply it with S and put limit S tends to infinity. S tends to infinity. So if you put limit S tends to infinity, I think you will get the value as 1. Okay. In the numerator you will have S square. In the denominator also you have the S square value. take the s square common and put s tends to infinity, you will get as 1. So answer is 1. Okay, let's come to the next question, guys. The next question on your screen is this. Tell me, for a unity feedback control system shown in the figure, the open loop transfer function is given as, this is our open loop transfer function, feedback is given as unity, the steady state error due to unit step input. Now unit step input, and this is a type 1 system, so it's 0. Okay, it's 0 for type 1 system. For unit step input, type 0 system will give you finite error. Okay, but for type 1 system, unit step input will give you 0 error. Okay, let's come to the next question, guys. The next question on your screen is this. Match the XYZ inferences XYZ about a system to the corresponding properties of the element of the first column in Routh table of the system characteristics. Okay, match the inference XYZ. So these are the XYZ. Okay, about a system to the corresponding properties of the element of first column of Routh table of the system of the characteristics. Okay, the system is stable. Tell me, guys, when the system is stable, when all the elements are positive in the first column. So X has to be P. Okay, the system is unstable. The system is unstable when there is sign change. Okay, so when any element is 0, there is a change in sign. Yes, when there is a change in sign, then we call that the system is unstable, because okay, the test breaks down. Actually, it not breaks down, but anyway, so this Z will go to Q. Okay, so X is P, Y is R, and Z is Q. X is P, Y is R, and Z is Q. Answer is Delhi. Let's come to the next question, guys. But before going to the next question, let me tell you, we have free workshop on 6th of September. So please attend this workshop at 7:30 p.m. This workshop will be taken by Rakesh Talleja sir, and the title of the workshop is Score 13 out of 13 in Engineering Mathematics in GATE. Okay, so you can register it, and link is given in the description. And for those students who are financially not that much strong, BYJU'S Exam Prep is giving you I mean, there is a option of giving the scholarship test. So you can give the scholarship test and get the scholarship up to 90%. You can register for it. The test is on the 3rd September from 9 a.m. to 9 p.m. You can give test anytime. Okay, from 9 a.m. to 9 p.m. So you can register for it and get the scholarship. Okay, guys, let's come to the next question. The next question on your screen is this. The transfer function of a linear time invariant system is given this. This is some transfer function. The number of zeros. So number of zeros means for what value of how many actually there are 4 zeros. Okay, we need to find the number of zeros in the right half of the split. How many zeros are in the right? Again, we can apply Routh. Okay, so if you apply Routh, then you can see that s to the power 4 then s cube. Now tell me, guys, first you have to write 2, then s square term, there is no s square term, 0, and then minus 2, then odd term minus 5, next odd term is 5, and next odd term is 0. Now s square, tell me, guys, s square 0 minus 10 divided by minus 5, that is 2, then this value into this value divided by this is minus 2. Now s to the power 1, tell me, guys, this is 10 minus 10 divided by 2, this is 0, and this is also 0. So obviously we cannot proceed. So that's why what I need to do, I need to take the derivative. So it's a auxiliary equation 2s square minus 2. Now you can take the derivative. So if you take the, actually it's an auxiliary equation. There is no need to write these terms. No need to write these terms, because below this you can calculate there are 2 roots, because up to the total 4 roots are there. Na? So below this equation, whether there is a sign change or not, that will be told by the auxiliary equation. Above this there is one sign change. It means one root is already in the right half. One root is already in the right half. There is also one sign change. There is also one sign change. Okay, from this to this there is sign change. It means above this equation there are 2 sign changes. It means 2 roots are already in the right half. What about other 2? Other 2 will be told by this auxiliary equation. There is no need to go down there. Okay, no need to go down there. Other 2 will be told by this. So from this you can see that s equal to plus minus 1. It means there are 2 sign changes above this, it means two poles are already in the right half. There is one more pole in the right half. There are zeros. So there is one more zeros in the right half of the S plane. Okay. So total zeros in the right half is 3. Then the test breaks down. But it doesn't happen all the time. Okay. It doesn't happen all the time. Okay. So that's why you are getting this wrong answer from Routh. So this is the very beautiful question, guys. You can say that it's a very beautiful question. I hope you understood it. Let's come to the next question, guys. The next question on your screen is this. The first two rows in the Routh table of the characteristic equation. Okay, these are the first two rows. Now we need to find the value of k, the range of k for which the system is stable. For what value of k the system will be stable? So for that you need to complete it. Okay. So s cube, s square. So if you look at this one, this is 2k plus 3. Okay, and this is 2k and this is 4. So s to the power 1. What is s to the power 1, guys? Tell me. This into this, 2k into 2k plus 3 minus 4 divided by 2k. Okay, and then 0, s to the power 0 is 4. Okay, so I have completed this. Now I need to find for what value of k the system is stable. So to make the system stable, the entire column has to be positive. It means 2k has to be positive. So k should be greater than 0. Okay, k should be greater than 0. Now this term should also be greater than 0. We know that the denominator is positive because k is 0. Denominator is positive. So numerator should also be positive. It means 2k into 2k plus 3 minus 4 has to be positive. This should also be positive. Okay. Now from here, how to calculate the k value? So you can multiply it. Okay, it will become 4k square plus 6k minus 4. This has to be positive. Okay, this has to be positive. Now can you factorize it? Let me simplify. It will become k square plus 3 by 2k minus 1 equal to 0. It has to be positive. It has to be positive. Let's see in what range of k this is positive. So you can calculate the roots of this equation. What are the roots? B square minus 4ac, because I don't have the calculator. So let's calculate the root. The sum of the roots has to be minus 3 by 2 and the product has to be minus 1. Okay, so how to calculate that? I think 2 and minus half. These are the two roots. 2 and minus half. You can see that the product is minus 1 and sum of the roots is 3 by 2. So is it correct? I think it should be minus 2 and this. Okay, yes, minus 2 and half. These are the roots. You can see that the product of the roots is minus 1 and sum of the roots is minus 3 by 2. Sum of the root is minus 3 by 2. So these are the roots. So what you can do is you can factorize it. K plus 2 into k minus half. It has to be greater than 0. Okay. Now from there you can calculate the range. You can apply the wavy curve. Okay. This is half point. This is minus 2 point. Okay. Now if you take the k as greater than half, this is positive. So you can see that this is positive when k is greater than half and less than minus 2. When k is less than minus 2 and k is greater than half, then this is positive. And this column is positive for k greater than 0 also. So you have to find the common range. So common range is k has to be greater than half. Okay, k has to be greater than half. That is the common range. Answer is Delhi. Okay, answer is Delhi. K has to be greater than half. This is the common range. Okay, so please check it. Let's come to the next question, guys. The open loop transfer function of a unity feedback control system. This is the open loop transfer function. The value of k at the breakaway point on the control system. So at the breakaway point, we know that repeated roots are there. So let's assume that at k equal to k naught, you have the breakaway point. So if I put k equal to k naught and if I write the characteristic equation, the characteristic equation will become 5s plus 5 plus k naught. This is my characteristic equation. Okay, gs divided by 1 plus gss. So with the help of that, I have written the characteristic equation and I have put k equal to k naught because I am assuming that at k equal to k naught, breakaway point is there. Now this is the characteristic equation. Now we know that at the breakaway point, roots are real and equal. So what you can do is, you can make the roots real and equal. It means discriminant b square minus 4ac has to be equal to 0. Okay. So from here you can calculate 25 minus 20 minus 4 k naught has to be equal to 0. So from there k naught is equal to 5 by 4. Okay. So at k naught equal to 5 by 4, the roots are real and equal. So this is at the breakaway point, k naught has to be 5 by 4. So this was a very simple question. Anyway, I hope you understood it. So guys, I think it's time to stop here because there are lots of questions that I need to solve, but I think I will take these questions in the next class. Okay. So I will take one more class, but only few questions are left behind. 1, 2, 3, 4, 5, 6. Okay, 6 questions are left behind. So I think I should take in the next class. These questions I will take in the next class. Okay. So let's stop it here, and the remaining question you can try. You can also try. These are simple questions. Even let me try. Okay, let's try these questions as well. For the path transfer function and the feedback path transfer function of a single loop negative feedback system are given. This is GS, this is HS. Okay, and feedback is negative. If the variable parameter k is real positive, okay, k is given as positive, the location of the breakaway point on the root locus, again breakaway point I need to calculate, but this time the location of the breakaway point is calculated. K is not required, location is required. Okay, k is not required, the location is required, but first you have to calculate the k value, then only you will get the location. Okay, or what you can do is, you can also calculate the location also. How to calculate? We write the k value. We know that 1 plus GSHS, 1 plus GSHS, this is our characteristic equation. 1 plus GSHS is equal to 0. This is our characteristic. Now you can calculate k value from here. K is equal to minus of s square plus 2s plus 2 divided by s plus 2. Now to find the breakaway point, you can take dk by ds equal to 0. Okay, so you can take dk by ds equal to 0. Now you can take the derivative. How to take the derivative? S plus 2 whole square. Here you have to write s plus 2 into derivative of this. Derivative of this is 2s plus 2 minus s square plus 2s plus 2 into the derivative of s plus 1 is 1. Okay, this is 0. So from here you can calculate the location of the breakaway point. So that will be 2s square. Let me write this: 2s square plus 6s plus 4 minus of this quantity s square plus 2s plus 2 and put it equal to 0. Now if I simplify this, it will become s square plus 4s plus 2 equal to 0. From here you can calculate the breakaway point. There are 2 breakaway points, but out of these 2, one is correct. How to check which one is correct? For that, I need to draw its root locus, and we have to see. Now if you look at this, there are 2 poles, and the 2 poles are on imaginary, I mean they are complex, and there is 1 0 at minus 2. 1 0 at minus 2. So if I see which part of the real axis will be the part of root locus, this will be the part of root locus. It means the breakaway point should be less than, actually it should be a break-in point. There will be break-in point. Okay, it's not the breakaway point, the break-in point. So the break-in point will be less than minus 2. You will get 2 values here, but the value which is less than minus 2 you have to select. Okay, so you can easily calculate from here. So that's easy peasy. Okay, let's come to the next question, guys. The next question on your screen is, the closed loop system is stable if the Nyquist plot of the corresponding open loop transfer function. He is saying the closed loop is stable. It is given that closed loop is stable. It means Z is 0. Okay, closed loop system, Z is 0. And we know that the number of encirclement of minus 1 has to be equal to Z minus P or P minus Z. P minus Z. If Z is 0, then N has to be equal to P. If Z is 0, N has to be equal to P. It means the number of encirclement of minus 1 has to be equal to the poles of 1 plus GSS, and the poles of 1 plus GSS are actually the poles of GSHS, open loop transfer function. We know that. So let's see the question. The closed loop system is stable if the Nyquist plot of the corresponding open loop transfer function, the closed loop system is unstable for sufficiently large value of k. No, I think something is missing in this question. I think some statement is missing, guys. Plot of the corresponding Nyquist plot of the corresponding open loop transfer function. I think something is missing. I think some diagram is missing because k is given and k is not mentioned anywhere in the statement. I think there is some correction in this question, guys. Okay, so maybe after correction we'll see. Okay, let's come to the next question, guys. The next question: the number and the direction of encirclement around the point -1 in the complex plane of the Nyquist plot. So this is the GS. Let's call it GSHS. If something HS is not given, by default we take HS as 1. Okay, we need to find the number of encirclement of -1. Okay, so how to calculate the number of encirclement of -1? So that's very simple, guys. We know that this is my GS. So characteristic equation will be 1 plus GSS equal to 0. So you can see that the closed loop system you can directly calculate. The closed loop system will become like this. This is our closed loop system, TS. Okay. Now it will be 1 minus S divided by S plus 5. Okay. So you can see that closed loop system is stable. Closed loop system is stable. Now how many encirclement will be there? So you can easily see that in this TS, 1 0 is in the right half of the S plane. 1 0 is in the right half of the S plane. And there is no pole in the right half of the S plane. It means the number of encirclement will be 1. Okay, because you are looking the closed loop transfer function. So if you are looking the closed loop transfer function, you can easily see that the closed loop transfer function is stable. It's stable. And the number of encirclement of -1 has to be 1. Okay, number of encirclement of -1 has to be 1. Okay, now it has to be 1. Now in which direction it should be there? The number of encirclement. So it should be in the same direction in which the contour is given, but the contour is not given. So we cannot say it anti-clockwise or clockwise because the contour should be provided to you. By default you can take the contour like this. Okay, or you can take the contour in opposite way also. So it all depends on the contour by default in which direction you are taking. So it's not sure. I mean, it can be anti-clockwise or clockwise, depends on the contour. Okay, so it should be provided in the question because by default you cannot take like this. You can also take it like this. Some book they take the contour like this as by default. Okay, they take the contour. If you look at the BCQO, they take the contour like this. In some other book they take the contour like this. So you cannot say clockwise or anti-clockwise, but encirclement has to be 1. Okay, so the number of encirclement of -1 has to be 1. Okay. Let's come to the next question, guys. The next question is this. In the feedback system shown, so this is our GS, the positive value of K for which the gain margin is exactly 0 dB and the phase margin of the loop is exactly 0 dB. This should be the K value. Okay, what can be the K value so that the phase margin and gain margin are exactly equal to 1? Exactly equal to 0 dB. First of all, look at the phase margin. Phase margin has nothing to do with the K. Phase margin. Because for phase margin, no. Actually, it has something with K. Why? Because for phase margin, we need omega PC. Okay? And for gain margin, we need omega GC. He's saying that we need to find the value of K for which the gain margin is exactly 0 dB. And the phase margin should also be exactly 0. Let's first calculate omega GC. How to calculate omega GC? It's very simple. We need to calculate the magnitude, and that magnitude has to be 1. At what frequency the magnitude equal to 1? First we need to calculate that. But the problem is we don't know the K value. If we don't know the K value, we cannot calculate that frequency at which this magnitude become 1 because K is required. Okay, so omega GC, it's not easy to find. What we can do is we can calculate omega PC. Or there is one more way. You can apply You can apply root locus as well. With the help of root locus, you can calculate that. We know that in the root locus, if I plot the root locus of this system, -1, -2, -3. And if I plot the root locus, this will be the part of root locus, this will be the part of root locus. Root locus will be like this. If you take this k value, at this k value, whatever this k value is, at this k value, omega GC is equal to omega PC. Omega GC is equal to omega PC. At this point, the system is marginally stable. Okay? And if the system is marginally stable, you can say that gain margin is 0 and phase margin is also 0. So we need to find this value of k. But you have to understand from where it came. So I have taught you this. Okay? So calculate the value of k for which the system is marginally stable. That value I need to find. Okay? And how to calculate that? You have to apply the Routh for that. Let's apply Routh. So it will become S cube. Let me write the characteristic equation. Okay? S cube plus let's write the characteristic equation. So the characteristic equation will become s plus 1 into s plus 2 into s plus 3 plus k equal to 0. This is our characteristic equation. So now let me simplify this. It will become s cube. It will become s cube plus, tell me guys, you can write it like this, no? S plus 1 into s square plus 5s plus 6 plus k. Now if you multiply, it will become s cube. Now the s square term, so 1s square plus 5s square, 6s square plus the s term, 5s plus 6s, 11s plus 6 plus k. Okay, so this is our characteristic equation, guys. Now s cube and s square, so it will become 1, 11. This is 6 plus k. Now tell me, what is s to the power 1? So it will be 66 minus 6 plus k divided by 6 and then 0. So if k is equal to 60, then the system will be marginally stable. You can easily see that. So this k has to be 60. So if k is 60, system is marginally stable. Omega GC is equal to omega PC. Gain margin is 0, phase margin is also 0. Answer is 60. Okay. So it's easy peasy. This way you can solve the problem. Okay guys, let's come to the next question. The next question on your screen is asymptotic Bode plot is given to us. GS is given like this. Now the value of K and P1, both positive. The value of P1, I need to calculate the value of P1. This P1 I need to calculate. So how to calculate, guys? You can see that if I take this 0.1 and 10 common, it will become K divided by x divided by 0.1 plus 1, x by 10 plus 1, x by P1 plus 1. What I have done is I have taken 0.1 common, I have taken 10 common, and I have taken P1 common. So there must be decrement of the slope at 0.1. You can see that I think this is this value is 0.1. I don't know whether this is 0.1 or this is 0.1. I think this is 0.1. This is 10 and this is given as 100. Okay, this is given as 100. No, it is the phase. It is the phase. Is it phase or? Yeah, it is phase. The asymptotic Bode plot of GS with K and P1 both positive shown below. It is not the, it's actually the phase plot. Okay, it is actually the phase plot. Now we need to find the value of P1. So how to find the value of P1? Guys, we know that if I look at the phase will be minus of 10 inverse of omega divided by 0.1 plus 1, omega divided by 0.1 minus 10 inverse of omega by 10 and minus 10 inverse of omega by P1. This is our phase. This is our phase. Okay, now you can see that if I compare this with this plot, then can we calculate this P1 value. How to calculate this P1 value? You can see that at point 1, the angle is almost minus 45. And this will give you minus 45. If you put omega equal to 0.1, it will become minus 45. It will be negligible. It will also be negligible. So you can say that it will be dominant at omega equal to 0.1. And it is showing minus 45 degree. At omega equal to 10, the angle has become minus 225. So what I can do is, or you can also see that at omega equal to 1, the angle has become minus 135. Minus 135. Angle has become minus 135 at omega equal to 10. Okay. Or you can also say that omega equal to 100. At omega equal to 100, the angle has become minus 270. So what you can do is you can put omega equal to 100 and put this angle equal to minus 120. If I put omega equal to 100, this will become 1000 minus 10 inverse of, this is 100 upon 10 minus 10 inverse of, tell me guys, 100 upon P1. That is minus 270. This angle is minus 270. And from there you can calculate the P1 value. Okay. From there you can calculate the P1 value. So you will get the approximate P1 value from there. So from the phase plot, you can do it like this. I hope you will get the correct answer. Now the calculation is your part. You have to solve it. Okay. Because I don't have the calculator. So please solve this question. It's easy peasy. Let's come to the next question, guys. The next question on your screen is this. In the feedback system shown below, GS is given like this. The step response of a closed loop system should have minimum settling time. It should have minimum settling time and has no overshoot. Now tell me guys, if it has no overshoot and minimum settling time, it means the system has to be critically damped. Okay? Because if the system is under damped, you can see that if the system is under damped, it will take some settling time. But if the system is critically damped, then you can say that there is no overshoot. Okay? There is no overshoot and it has the minimum settling time, because if the system is over damped, it will take large time to settle. Okay, so for what value of K system is critically damped? That is asked. Okay, so it's very simple. Let's calculate the characteristic equation. It is s square plus 2s plus k equal to 0. So for what value of K the system is critically damped? You can calculate from discriminant b square minus 4ac equal to 0. K has to be 1. If K is 1, system is critically damped and you will have no overshoot and minimum settling time. It's easy peasy. Okay guys, so this was the last question. I hope you enjoyed this session. Okay, don't forget to subscribe our channel, like this session, and please press the bell icon so that you get the notification whenever my sessions are live. You can also join BYJU'S exam prep mobile app. Go to the Google Play Store, download the mobile app from there and install it in your phone. You can also watch free classes from our mobile app. So this is all for today's session, guys. See you in the next session. Thank you and take care. Bye.